In this video, we'll actually use the timer to directly toggle a pin. And this means that we don't need to write code inside an interrupt service routine or something like that to toggle a pin high and low. The timer can do it directly, and in this case we don't even need an interrupt service routine at all. What we'll do is apply it to something practical. So we'll apply it to toggling a pin to drive a hobby servo. Hobby servos, or there's small servos, are often used in model aircraft and small robots, and even some bigger robots as well. And they essentially require a 20 millisecond signal, a square wave, to be supplied to them, and the on to off time ratio of that sets the position of the servo arm. So if we have a on time of 1.25 milliseconds out of that 20 millisecond period, will be over on one side of the servo. If we have 1.75 milliseconds, we'll be over on the other side of the servo, so rotated about 180 degrees. And if we have it somewhere in the middle, about 1.5 milliseconds, the servo arm should be approximately in the middle. And some servos have a greater degree of rotation than others, so they'll have a further range of motion. Having seen that, we realise that we need to create a signal that's a period of 20 milliseconds and an on time of between 1.25 and 1.75 milliseconds. So let's go ahead and write some code. So we'll set up everything in our init device area, and first thing we need to work out is what's our period going to be. So TA0 CCR0 is equal to, now we know our period needs to be 20 milliseconds, and 20 milliseconds is a fairly long length of time, particularly when we're running at 8 megahertz. So we're going to slow the clock down somewhere else and scale it down to be a 1 megahertz clock. So we'll come back to that in a sec. The other thing is we're going to use a different mode to drive this. So we'll make a few notes here. So divide to 1 megahertz clock and use up down mode. Now in our data sheet, if we look at the up down mode, we have an example of it being used here, where the up down mode, the period for one complete cycle is actually double what's stored in TACCR0. So we've got TACCR0 there and 0 there, so the timer counts up all the way and then it has to count down all the way. So our period is essentially going to be double whatever we've got stored in there. So that helps us actually write our code. So what we need to say is 20 milliseconds divided by 2, because whatever we put in there is double, is equal to 10 milliseconds. And 10 milliseconds divided by a 1 microsecond clock pulse, because 1 divided by 1 megahertz equals 1 microsecond. That gives us a value of 10,000 that we put in there. So just going through the maths again, 10 milliseconds divided by 0.000001, so 1 microsecond, gives us our 10,000 value. Okay, that's our period. Next we need to work out what our on time is going to be. And this is going to go in the TA0 CCR1 register. So we'll just make a note, this is the on time. And we can calculate what the on time is going to be for 1.25 milliseconds, and we'll calculate it for 1.75 milliseconds. And everything else is going to be between those ones. What we need to remember is we need to divide these things by 2 because we're the up-down mode and everything's doubled. So 1.225 divided by 2 is equal to 625 microseconds. 1.75 divided by 2 is equal to 875 microseconds. We remember our clock pulse is 1 microsecond based on our 1 megahertz clock. So the value that we put in to achieve our 1.25 milliseconds is 625. And the value we put in to achieve our 1.75 milliseconds is 875. That will delay for 875 microseconds, and we double that because we're in the up-down mode. It'll give us our full range of 1.75 milliseconds. So let's set this to 625, and that will start us off at a 20 millisecond period with a 1.25 millisecond on time. We also need to set up another register to actually toggle the pin for us, and this register is the TA0 CCTL1 register. This register corresponds to our timer compare register, this one here. So depending on what pin that we're using, we need to use a different register. The pin that we've got in our microcontroller, which breaks out to the servo connection, is based on this particular capture compare register and pin. So if we look at our data sheet again, we need to put this into a mode to actually toggle the pin. So we'll come down to that particular register, and we're interested in the output mode. We've got a few different output modes here to choose from depending on what we want to do and depending on how things are set up. So we could have it toggle each time it hits a certain value, which is good if we're doing a square wave or something like that. In this case, we're going to use the toggle reset command. When our timer count is equal to the value in TACCR1, it will cause the output pin to toggle. And when our timer count is equal to the value in TACCR0, it will reset the output pin to 0. This will allow us to remain in sync so that even if we start out of phase with our toggle, it will quickly get back into phase within one cycle. So our bits that we need to set in this register, bits 7, 6 and 5, we need to set them to 0, 1, 0. In other words, we need to just set bit 6 to be a 1. So we'll set bit 6 in here. We then need to set up the control register and turn it all on. So our control register, and there's a few things that we need to adjust here. If we look at our control register, we're going to be using the SM clock, which is our 8 megahertz clock. But then what we want to do is divide that clock down. So we divide it by 8, and that will bring it down to the 1 megahertz that all our calculations are based on. We'll also be saying this needs to be in up-down mode. We've talked about up-down mode and how it works. So we need to set bits 5 and 4 as well. So the important bits that we need to set in this case are bit 9 for SM clock, bit 7 and 6 for the input divider, and bit 5 and 4 for our mode control to put in up-down mode. So let's do that now. Okay, there's one more thing that we need to do, and we need to enable the special function of the actual pin that we're using. This will actually connect it to the timer. So we say P1 SEL, P1 special function select, and the pin that we're using is pin 2 on port 1, so bit 2 we put in there. Okay, if we hit go, we can have it run. You'll notice there's nothing in our while loop there, so no code actually running. But what we can see is if we look at our oscilloscope trace here, we have a nice period which is 20 milliseconds between these two pulses. And our on time, if we zoom in on one of those pulses, is right on 1.25 milliseconds. Okay, that example was a bit static. How about we take it up a notch by actually changing our on time to off time? So in this previous example, the servo would be fixed at one position, but really we actually want a servo to be fixed at one position. We want to move it and make it do something. So let's try a bit more code. So write a bit of code to actually change that servo position. So we can say if TA0 CCR1, this is the on time, is less than 875, that's the value that we had in there, we want to increase it. So that will step it up. Otherwise, so we say else TA0 CCR1 equals 625. That was our low and high values we calculated before, 625 and 875. Okay, now the problem with that is it'll run so fast and the servo won't actually have time to keep up with us. So we need to put a delay in there. So we'll put a delay loop in here. So we'll delay for 30,000 cycles. We have to slow this down considerably. And we've got our delay loop in there. Let's have a look now and see what we've got. So we run our code. If we look at the oscilloscope, we can see our on time progressively getting larger and larger and larger until it hits the 1.75, and then it sets itself back to 1.25 and goes on and on and on there. And if we look at the actual servo, we see the servo arm sweeping as well. So the servo arm sweeps from one position to the other reasonably slowly, and then it flicks back as it hits the 1.75 mark and flips to the 1.25 mark. So there's a brief example of how we can actually use a timer directly to trigger a pin without having to call interrupts or anything like that.